Hey grade 6, new video for you guys today. It is the third of our transformations that we're looking at in this geometry unit. It is called rotations. Hopefully by the end of this lesson and the end of your practice in the workbook, you can do things like rotate points and shapes 90 degrees around a given center and verify that rotations take polygons to congruent polygons. So notice that we're only focusing on 90-degree rotations. The next lesson in the workbook focuses on other ones like 180, 270, that kind of stuff. But for today, we're just focusing on 90 degrees. So the first thing that we need to make sure that we're aware of is just the difference between clockwise and counterclockwise. Clockwise will go, well, for me it goes this way, and for you it will go the other way. But if we turn this arrow 90 degrees clockwise, where will it point? And so what we can do is we can just bust out our arrow, and if we go clockwise, that means we're going to go this way, and that looked really small, and so I'll see if I can punch that up just a little bit. Nope. Yeah, so it's going to end up going this way. Maybe let me punch it up now. There we go. That's the way it's going to point. It says, from the dark arrow, draw an arc showing the given turn, and then draw the arrow after turning. So we're going to draw some stuff, just make sure that they're the right thickness. All right, so if we are drawing 90 degrees counterclockwise, that means going this way. And so after 90 degrees counterclockwise, it'll be pointing that way. 180 degrees clockwise means it goes that way. And so after we rotate, that's the way it'll be pointing. A 90-degree clockwise turn will be going this way. And so after rotating, it'll be pointing this way. And 90 degrees counterclockwise means it kind of goes up to the left sort of thing. So after we rotate, it would be pointing this way. So the next thing that we're going to do is sort of learn how to rotate a point around another point. In this case, it's 90 degrees clockwise, and there's a few steps that we'll try to go through together, and I'll try and show them to the best of my abilities on this program. So step one is to draw a line segment, OP, and then measure its length. So I will try to do that, and so here we go, and sort of, yes, kind of. The next step is to draw an arc clockwise to show the direction of rotation. So point P is going to go clockwise like that direction. The next step is to place a set square so that it fits a couple of points. That the arc points at the diagonal side of the set square. Now, I'm not sure if anyone really knows what a set square is. So let's maybe try and figure this one out. So a set square is like a geometric tool that looks similar to this. It's basically a 90-degree angle and then kind of two 45s. There's another kind of set square that's got a 30 and a 60-degree angle. But basically imagine that this is like a ruler. And so what you want to try to do is get it so that, I'm trying to orient this parallel to OP. You want to try and get it so that that the diagonal line, that the arrow that I drew or that you drew is pointing at the diagonal line. And so what happens is you're going to want this set square to sort of be pointing this way. And the reason for that is you're going to have this point. It's going to be hard to see, but like right here is sort of your rotated point. And so when I'm just going to get rid of this set square for my set square for a quick sec, and my arrow here. So after I've done this rotation, and I'll just draw another line. After I've done this rotation, my point P, or my P prime, this is where it's going to end up after a 90-degree clockwise rotation. And then I have two other steps that I just completely did not pay attention to, which is to draw a ray from point O along the side of the square corner, and then on a new ray, measure and mark the image point P prime, which I did, so that OP prime is the same length as OP. And so I would have this line like that as well, so that the two lines are equal, that they are the same length. All right, so now we're moving on to this new concept called center of rotation. And what center of rotation says is that the center of rotation and the points we rotated were all grid line intersections. So the image points are also grid line intersections, yes. When you perform a transformation such as a reflection, a rotation, or a translation, some points move and some points do not. So then some things to consider. Are there any fixed points in a rotation? Possibly, depending on what is being rotated and around what point it's being rotated. Are there fixed points in a reflection? Yes, there can be. Again, depending on where the mirror line is, and we learned about mirror lines and reflection lines in the other video. In a translation, I don't believe that there are any fixed points in a translation. It's the whole object is being slid around, up or down, left or right, and so all the points in a translation move. So it's only in rotations and reflections where you can get fixed points. Now, what we're going to try to do here is rotate this triangle around this point. We're going to go 90 degrees clockwise, so it's going to be going sort of like, you know, up to the left. Now, what I'm going to do is I'm actually just going to count spaces. Okay, so I'm going to imagine, let's see, point A, it's going to be going clockwise this way. So I got to go one space over and 1, 2 down, and then 1 space, 2 spaces over and 1 space down. So my new A point is going to end up right there, and that's going to become my A prime. After and guys, all I did was I counted spaces, and it's a bit tricky sometimes. You got to keep it sort of straight in your head, but I just counted over 1 to the left and then down 2, and then so I went over 2 and down 1. So the numbers themselves, you can use them again. It's just whether or not they go up or down, right or left. You have to try to keep that straight. And so this one, point B is a bit easier because it's just going to be, again, 90-degree rotation down this way. And you're going to go 1, 2, 3 over and then 1, 2, 3 down. So that's going to become my B prime point. And then what I can actually do is just, actually, I'm going to use a straight line because my freehand lines are not amazing. And so you can just connect A to B, or A prime to B prime. Now, my C point is going to go over 2 to the right and then 1, 2, 3, 4 to the origin, which means I'm going to go 1, 2, 3, 4 to the left and then up 2. And this is going to become my C prime point. And then what I can do is I can draw my lines from, you know, B prime to C prime, and then my other line from C prime to A prime. And one of the ways to check if you've done the rotation correctly is you can actually measure this AC prime line with CA prime. If these two lines intersect here at a 90-degree angle, if they're perpendicular, then you've done the rotation correctly. Now this does indeed represent a 90-degree rotation to the right. Sorry, clockwise. All right, so a couple of things just quickly. If two triangles are congruent, this means that one is not necessarily a rotation of the other. Okay, that one's not true. So the next point is to use the grid to rotate the triangle 90 degrees clockwise around the vertex O. So this whole triangle is going to get swung down 90 degrees this way. And so what I'm going to do is I'm just going to clone this thing, and I'm going to do the rotation. So that's a 90-degree rotation. And then I'm going to actually just orient it here, because that represents a 90-degree rotation. If I can just draw it freehand, that this point has swung down 90 degrees to here. So then the next question is, how could we use right triangles to rotate this line segment 90 degrees clockwise? And what they're trying to get at here is if if we make this shape into a triangle, if we take this line and just sort of extrapolate a little bit and just imagine for a second that this is, a triangle, we could imagine that we're taking this shape and you could again rotate it 90 degrees around this point so that you would end up with, what is it, 1, 2, 3, 4. Oh, still need my line tool. So you'd still have this 4 down here, and then you can imagine that you've rotated the shape. This program's hard to work with sometimes. That this has been rotated. If you imagine that this is 90 degrees, and then what you can say is, well, these were my so we were just imagining that it was a triangle, but this one actually is a 90-degree rotation clockwise. So in the workbook, what you can do is get a chance to try to rotate the line segments by only imagining the triangles, not actually drawing them. It goes on to talk about draw slanted line segments and label one of the vertices as the center of rotation. You can do that. You can pause the video and try that, or you can practice some questions in the workbook. So this next part here, how can I rotate point A 90 degrees, again clockwise, around point B? And again, what we can do, and this is a good trick for 90-degree rotations, you can just do some counting of the grid lines. So this would go over 1, 2, and then up 1, 2, 3. So I can move this over 1, 2, 3, and then up 1, 2, and I can lost my spot. 1, 2, 1, 2, 3, 1, 2. So that would be my point, my A prime point. And again, all I'm doing is not a grade A. All I'm doing is I'm just counting grid squares. And again, you have to be careful and you have to pay attention to how you're counting, but you can do it that way. So then just one last thing. This kind of wraps up and summarizes reflections, rotations, and translations. And so the length of the sides in a reflection, same. The size of the angles, same. Orientation has changed. Position on the page, it moves. In a translation, again, length of the sides the same. Size of the angles, same. Orientation is the same, actually, because all you're doing is sliding it around. And the position on the page moves as well. Rotation, the length of the sides doesn't change. The size of the angles stays the same. The orientation is changed, and the position on the page, again, they all move. Okay, so that's just sort of a quick way to wrap up and summarize how shapes move around on a grid if you're doing these kinds of transformations: reflection, translation, or rotation. So there's practice in the workbook on 54, 55, and 56. And so I encourage you to try it out. And, yep, do your best. Thanks for watching. Have a great day, guys.